Today I'm working through the Chapter 2B review worksheet. Number 1, we have to come up with a polynomial function that has the following zeros listed. X equals 4, x equals negative 10, x equals 3 plus 7i, which means its conjugate is also a root, x equals 3 minus 7i. We go put these into their corresponding factored form. I'm going to go ahead and FOIL these first two out. X squared plus 6x minus 40. With these, I'm going to choose to use the box method, and I'm going to come over here and do that for us. Going ahead and filling it in. Some of these terms should cancel out. The negative 7ix. Actually, this one's a positive. It cancels out with the negative 7ix here. The negative 21i cancels out with the positive 21i. And finally, when I multiply those, I get a plus 49. X squared minus 6x, 9 and 49 is 58. Now I can either box these out or FOIL them out. Just for sake of space, I'll just FOIL them out. X to the 4th minus 6x cubed plus 58x squared. Multiplying this by each of those, that would be a plus 6x cubed minus 12x squared. 6 times 58, I believe, is 348x. And then finally negative 40 times each of those. And I'm just lining up all the like terms to save myself a little bit of work later. This would be a 240x. And then finally 40 times 58 would be a 200. I'm going to have to do that over here. Looks like it's a 2320. X to the 4th, those cancel out. That would be a 6x squared, a 588x plus the 2320. Okay, checking my answer. 6x times 30, or 6 is a negative 6x squared, so this whole term ends up being negative 18x squared. Alright, moving on to question number 2. They want us to match the polynomial function. First of all, I can quickly see that it has to be a degree that's odd because it has opposite end to behavior. If you look at the left side of the graph, it looks like it's crossing at negative 2 and it's a bounce, so if x is equal to negative 2 and it has a even multiplicity, that would be a multiplicity of 2. We take a look at this one, 1, 2, 3, 4, 5. Actually, 1, 2, 3, 4. We know x is equal to 4, and because it is passing through, that means we would have to know it's a odd multiplicity. So as I'm scanning through here, the only multiplicity that would correspond with that would be a multiplicity of 3. answer is -2 multiplicity of 2 and 4 with a multiplicity of, okay, so my answer is D. Number 3, they want us to list all the possible rational zeros. That means I'm looking for my p's over my q's, so I'm looking for factors of the constant divided by factors of my coefficient, which is just 1. So I've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, and 9. Now I can start matching these up. I would have 4 and 18. I have 3 and 24. Finally, 2 and 36, and 1 and 72. I'd have to go use synthetic division or the remainder theorem, or if I had my graphing calculator, I could plug it in. I'm going to go ahead and try a few, and then we might just plug it in our calculator. I'm going to go look at f of 1. That would be 1 plus 6 plus 17 plus 54 plus 72. Well, that's going to be all positive, so I know that it's not that. Let's go try f of -1. That would be 1 minus 6 plus 17 minus 54 plus 72. Quickly check that. I ended up with a remainder of 30, so I know it's not that one. Let's go try one more. How about f of -2? So that would be 16. 6 times -8 would be a -48. 17 times a positive 4 would be a 68. 54 times a -2 would be -108 plus 72. I ended up with a remainder of 0. That means I know -2 is a root. I'm going to go and synthetically divide. Now I got to go find another solution in there. From here, I would have x cubed plus 4x squared plus 9x plus 36. I believe -4 is going to end up being a root. And one way I quickly knew that, some of this you might have learned this from last year, I could do factor by grouping. If you take a look, these two have an x squared in common. I would be left with x plus 4. These two have a 9 in common. I'm left with x plus 4. So take a look. We could factor out an x plus 4 out of each one of those, and I'm left with x squared plus 9. Don't forget, if we're trying to write this as a linear factorization, I also have the x plus 2. And that means I can factor this down here. Some of you might remember it's x minus 3i, x plus 3i. If you don't, you would come over here, we would solve this. We end up with x's plus or minus 3i, and that's how we can do those factors. Moving on to number 5. 5, similar to the very first one. We have x is equal to 3, x is equal to I, we know x is equal to -I, and we have one other thing, that's f of 2 equals 30. Let's go put it into its corresponding factors. We're going to multiply those conjugates. That would give me x minus I squared, which ends up being x squared plus 1. Continuing on, I've got x cubed minus 3x squared plus 1x minus 3. However, I've got this piece over here I have to deal with. That means I actually have a coefficient coefficient out in front. So I'm going to plug in this is x, this is y, and solve. We've got 30, plugging in 2. I've got 8 minus 3 times 4, which is 12, plus 2 minus 3. I'm going to simplify that up. Negative 4 and negative 1 is negative 5a equals 30. A is equal to negative 6, so I'm going to take negative 6, put that out in front, and distribute. Negative 6x cubed plus 18x squared minus 6x plus 18. I'm going to confirm my answer is correct. Moving on to question number 6. Use limits to describe the end behavior of the following. Y equals negative 8 over x plus 2. If I wanted to put this in fireproof form, just trying to emphasize some extra things here. This graph is shifting left 2. It is reflecting across the x-axis, and I have a vertical stretch of 8. So let's make a quick sketch of my graph. We know it's going left 2. This asymptote isn't moving. I'm normally in quadrants 1 and 3, but again it's reflecting across the x-axis. That's going to put me down here and here. I'm going to take that square root of 8 to get an approximation where